Okay, so our unit that we're going to be doing today is up until this point, prior to finals, if you can remember that, we were doing a lot with radicals and simplifying them, okay? So now what we're going to be doing is solving. So a lot of the next topics are all about finding the answers, okay? Finding what the solutions are. So we have a radical expression and we want to actually find the answer. What would be the solution for that, okay? There's 3 steps that go into that, okay? And they're listed here underneath the bullet points, and what I'd like to do is just number those so it's easier to follow along. So if I do 1, you just put like a 1, a 2, and a 3. Okay? So these are steps, and so basically what we're going to be doing is we have in front of us an equation, okay? There's an equal sign, there's a variable, but the variable now is underneath a radical sign. So it's not just so easy as getting x by itself. The purpose is to get the variable by itself, but how you go about doing that with a radical, you have just one extra step in there, okay? So we're going to go through the process. There's 3 processes. The first one says isolate the radical expression on one side of the equation. Then the second one is going to be raising both sides to the same power, and then the third one is checking it. So those are the steps. So let's walk through that for a second. When I talk about isolation, what do we mean about isolation? What does that mean?
You try to have only that on that side. So in this case, you would subtract 2. Because 2's on that side, it needs to be on that side.
Okay, correct. So if you can recall back in the days of absolute value, if let's say I had absolute value of x plus 2, and then minus 4 equals 0. Let's say I had that, and I said you had to isolate the absolute value because we wanted to get that all on the one side, right? Remember how we got everything over there. So if there was a constant, we move it over. If there was a coefficient in front of it, we divide it by it, whatever. And the goal was just to get this part right here all by itself, right? So that's the same concept, but now we have it with a radical sign. So you can see we have a radical expression because there's the wonderful radicand, right? So we want to get it all by itself. So when I say isolate, that means make sure that's the only thing on the left-hand side. So we work with moving the constants over and then dividing by or multiplying by any coefficient that's in front of it. Okay? So first thing I want to do is get rid of the 2. So I'm going to subtract the 2 here because that's the constant. Okay? And then that's going to go away, and I'm just left with then the radical of 3x minus 2, and that's going to equal 4. Okay? So that's step number 1. Okay? So now the next step is raise both sides of the equation to the same power. Because we have a radical sign, we have this thing called that index. Remember that? If you don't see it, it's an implied 2. If it's a 3, it's a cube root. If it's 4, it's 4th root, etc. Okay? So whatever power that is on the radical sign is what you want to raise everything to. And raising means everything goes in a parenthesis, okay? And then you put that power on top, right? So that's an implied 2, correct? So therefore I'm going to raise this to the 2, and then I'm going to raise this one to the 2. Okay? So this is number 2. Okay? When I do that, what's going to happen is this radical sign is going to go away. And the reason why that goes away is as follows. If I have, let's say, the square root of 2, and I'm multiplying by the square root of 2, right? That's the same thing as the square root of 2 squared, right? Well, what's the square root of 2 times the square root of 2? That can be the square root of 4. And then what's the square root of 4? That's just 2, right? So whenever you raise anything to the power of what it is, you're multiplying it by itself so many times that it's like you're pulling out that hand. Remember when we did those books, when we pulled them out? You're creating that situation, and that radical sign goes away, okay? So that's how come that works. So this is going to cancel. So I'm going to have 3x minus 2 over here, and then I have the 4 squared, which is going to be 16. Okay? And the reason why you have to do it to the right side is anything you do to 1, you have to do to everything, otherwise you've changed the equation. Right? So now everything is still the same. So at this point, you pretty much could probably solve for x, right? We all know how to solve for x. Move the constant over, divide by the coefficient. So I'll do 3x equals 18. X equals 6. So the trick really is getting that power, right? Well, so then my step number 3 though says check for extraneous roots. So basically we have to take this value now and we have to check. Okay, before we didn't necessarily have to check, we have to check now. And if the answers do not equal each other, then that is not actually an answer that fits. Okay? So we have to check. So number 3 is you have to check. Okay? So then you just take this value and substitute into your original equation. So I'll take the 2, I'll do plus square root of 3 times the 6 minus 2, and that's going to equal what? 6. Okay? So now to solve, so I have 2 plus the square root of 18 minus 2 equals 6. I have 2 plus the square root of 16 equals 6. And so it's 2 plus 4 equals 6, 6 equals 6. Therefore, that is a solution. Okay? So that is a solution. That is your answer. Okay? Questions on that? Alright, so let's look at this next problem here, and I'm going to have you guys try solving this equation here using your 1, 2, and 3 steps. Okay? So I'm going to have you guys try that on your own. Alright, so just real quick, going through this, number 1 is you want to isolate, so I'm going to bring the constant over, so it's going to be the square root of 5x plus 1 equals 6. Then I'm going to square both sides. So, or I'm going to raise it to the power, okay? So that's something you want to make sure. Don't just automatically square. You have to look to see what the index is. So if the index was 3, you would want to cube it. If the index was 4, you'd want to take the fourth of it, okay? So I'm going to square both sides. Okay, so that becomes 5x plus 1 equals 36. Subtract the 1, so 5x equals 35, and then x equals 7. So number 3 is to check it, and you guys want to make sure you do that in your homework to get full points. Okay, so then I'm going to plug it in, the square root of 5x, 5 times 7, plus 1, minus 6 equals 0. So this is going to be 35 plus 1, minus 6 equals 0. So it's going to be square root of 36 minus 6 equals 0. And that's going to be 6 minus 6 equals 0, and 0 equals 0. Okay? Because the left and the right side equal, that is the solution, that is my answer. Does that make sense? Okay. Alright, so let's look at, I'm going to look at this one here, right below it instead. Okay? So, we have now 2 radical expressions on the same side, okay? So to isolate it, basically it says you want to have the radical expressions on one side. So are the radical expressions on one side? They are. So then number 1 is already done. Okay? So now what would be number 2? What would we want to do? Yeah, so we want to raise both sides to the power, okay? So they're both squared, so we're going to do the square root of 3x plus 2, square it, minus, and then parentheses the square root of 2x plus 7 squared equals 0 squared. Even though it's 0, you still want to square it. Okay, so make sure every term, basically every single term needs to have that power applied to it. Otherwise you've changed the equation. Okay? So at this point, these are going to cancel, so I'll just be left with 3x plus 2 minus 2x plus 7 equals 0. Now, the reason why I put the parentheses around the 2x plus 7 is because this whole radical expression is one expression, right? So that negative is going to get applied to each item. Okay? Well, I haven't applied it yet. I just want you to notice why I have parentheses around it. Okay? Now I will apply it, so that'll be 3x plus 2. That'll be minus 2x, and that'll be minus 7 equals 0. Okay? So just realize this whole expression is 1, so you can't get rid of that. If you have a negative sign, you can't get rid of it. You have to apply it to each term. Okay? Does that make sense? Now you just solve for x. So go ahead and solve for x and see what you guys get. Okay, so what did you guys get? Let me get an answer. X equals 5? Okay, so if you combine the x's, I'm going to get a x, and that's going to be minus 5 equals 0, so then x equals 5. And then when you check it, okay, I'm going to have the square root of 3 times 5 plus 2 minus the square root of 2 times 5 plus 7, and that equals 0. And so this can be, what is this? 15 plus 2 is the square root of 17, minus 10 plus 7, which is minus the square root of 17 equals 0, so 0 equals 0. So that works. Okay? Alright. So we're going to look at this next example. Okay? This one right here, the 2x plus 1 to the 0.5 minus 3x plus 4 to the 0.5 equals 0. Okay? Well, what is 0.5? How can that be written as a fraction? Claire? 1/2. So I could write this as 2x plus 1 to the 1/2 minus 3x plus 4 to the 1/2 equals 0. Well, what do I know about exponents that are fractions? What do I know about the denominator? What does that represent of a radical expression? It does represent the index. Okay, so this is really a square root then, isn't it? So remember how 1/2 equals the square root, 1/3 equals the cube root, 1/4 equals the fourth root, right? This becomes the index. Okay? So at this point, I could really rewrite this as 2x plus 1, the square root of 2x plus 1 minus the square root of 3x plus 4, and that equals 0. Bless you. Am I able to solve that now? Yes? So this is the exact same problem that we just had right here. I was going to say next door. Over here. Okay? So then you can go ahead and solve that. Okay? So go ahead and see if you can't find the answer for x on that one. X equals -3. Okay, so x equals -3. Now, do you want me to go through that process, or are you guys good with that?
Can you go through it?
Okay,
I'll do the negative.
Okay, so then when I square both sides, I'm going to get the 2x plus 1. I'm going to get a minus 3x plus 4, but it's in parentheses, equals 0. So it's going to be a 2x plus 1, a minus 3x, and a minus 4, and that equals 0. Okay, so I'm going to get a negative x, and I have a minus 3 equals 0 when I combine my like terms. Bring the 3 over to the other side. So negative x equals 3, divide by -1, so x equals -3. Okay? Now, questions on that? Now, when you go to check it, here's the tricky part. You go and you plug it in. So I'm going to plug in my square root of 2 times a -3 plus 1. I'm going to get a minus square root of 3 times a -3 plus 4. Okay, that should equal 0. So when I do that, I'm going to have a -6 plus 1 minus a -9 plus 4 equals 0. So I have the square root of -5 minus the square root of -5 equals 0. At this point, you'd be like, oh, well, that equals 0 equals 0. But here's the thing. What do I have underneath the square root sign? I have a negative square root. Can you have a negative square root? Well, I can't have a negative. There's two negatives equal positive, right? So there's square root of -5 is not going to happen. So this actually becomes a not going to happen solution. Right? So it appears to be correct, but because it is a negative square root, you cannot have that. So that's a no solution. Until tomorrow. Or till Thursday.
Oh, no, why?
Okay? Alright, so does that make sense? You see what I'm saying with the negative square root? Okay? Alright, so now, let's look at this last example on the bottom here. So here we have a 3, 5n, minus 1 to the 1/3, minus 2 equals 0. Okay? So how you can rewrite the 1/3? How can you rewrite the 1/3?
Square root with a 3 in front.
Okay, a third root. We'll do a third root. Okay? So let's rewrite that. So 3 third root of 5n minus 1 minus 2 equals 0. Okay, so I took that 1/3 and I just made it a third root. Cube root.
Now do we have to cube it to get rid of it?
Right. So first of all, we need to do number 1. What's number 1? What does it tell us to do?
Get everything over this.
We want to isolate it. So go ahead and see if you can isolate that and see what you guys get. So when you guys isolate it, hopefully you got it to look like 3, you'd have the cube root of 5n minus 1 equals 2. And then you can divide by 3. So you'd have the cube root of 5n minus 1 equals 2/3. So that's number 1. Okay? Because it's a 3 in front of it, it's like 3 is being multiplied by that. So you want to divide by it. Okay? So my 3 I have there is being raised to it. Okay? So at this point now, I want to do number 2, raise it to the power. Well, what's my power? It's 3 now, so it's not 2. So now I'm going to raise everything. So number 2 is raise everything to the 3rd power. So I'm going to have the cube root of the 5n minus 1 to the 3rd power, and that's going to be equal to 2/3 to the 3rd power.
Where's the n go?
Oh, n. Right there. It was just slow. Yeah. Okay, so now the 3rd power and the 3rd root cancel each other out. Okay, so I'm just going to go up here to give more space. So I'm just left with 5n minus 1 equals. Now the 3rd power gets applied to the 2, and the 3rd power gets applied to the 3. Okay, so this is going to be 2 to the 3rd all over 3 to the 3rd. Okay, because I'm raising the 2/3 to the 3rd power. So what's 2 times 2 times 2? 8. And then what's 3 times 3 times 3? 27. Okay. So good on how we got number 2? Okay. At this point then we solve for n, so I'm going to add 1 to the other side, right? Well, if I add 1, what's my common denominator? 27, so I'm going to add 27 over 27. That's my 1. Does that make sense? I added 1 to the other side, right? And so I added 1 as 27 over 27, because you have to combine the 2.
Okay, so you added 1 to
So I wanted to get rid of, so what I did was, I did 5n equals 8 over 27 plus 1, because I did a plus 1 here, I do a plus 1 here. Okay? But 1 is really 27 over 27, because I have to combine the 2. Right? Okay, so at this point, here, then what's 8 plus 27? Anyone? 35, right. So then I'm going to get 5n equals 35 over 27. What would I need to do now to solve for n?
Divide by 5.
Divide by 5. So I'm going to divide by 5. I have n equals 35 over 27. I'm really multiplying by 1/5, right? Dividing by 5. Right? So if I'm dividing by 5 and divide by 5 here, that's really like multiplying by 1/5. Okay? So at this point, you could multiply 27 by 5 and then reduce, or you could just reduce this way. 5 and 35. You can reduce, that's 7, and that goes away. So that just equals 7 over 27.
What? If it's 1/5, you can't... Alright.
Okay, so if I take 35 over 27, and I divide it by 5, right? You guys good with how I'm dividing by 5? Right? Well, dividing by 5 is really putting it on the denominator, right? So if I do that, I could do 35 and then over 27 times 5, right? I can multiply that out and then reduce, or I could see that 5 goes into 35 7 times. Because it's a cross multiply, right?
Why would you 5 over 1?
Because I'm dividing by 5. I divide by 5 on both sides to get rid of the 5 here, and that gets rid of the 5 on this side. So to do that, it comes down the denominator. Does that make sense? You could just do 27 times 5 and then reduce. Or you could see that 5 and 35, again, remember if the numerator and denominator you can reduce, right? I can take 5 out of the 35 and it becomes 7. Does that make sense?
Yes.
Okay. Good?
Yes.
Okay, if you check this, you guys, it would not be a solution. Oh, no, it would be a solution. This one is right. I'm not going to have you check this one, though. Okay, oops, sorry. All right, questions on that? So you're good with the power, raising it to different power? Okay. On this next problem here that I kind of wrote all over, it's kind of hard to see, okay? You would, again, bringing the radical all to one side, and then you'd go through the steps again. So you'd add the square root of x on this side, and then you would square both sides. Okay? I'm not going to do that because I just took off all the page here, but when you do it, if you try it out, you should get x equals 12. So that is going to be your answer, and if you plug it in, it's no solution. So that would be your check. Okay? So I'm not going to walk through that one, but you could bring this one over to that side, and then you square every term, or raise to square each term. Okay? Good? Flip.
X equals 15.
12. X equals 12. So yesterday, you guys remember how windy it was? How crazy windy it was?
Yeah.
Right. Well, so we started talking about this problem that we have in front of here, and it has to do with the Buford wind scale. Have you guys heard of the Buford wind scale?
This is how windy it was.
Yeah, the Buford wind scale is like a 0 to 12 ranking, and based on the Buford wind scale, it tells you like how intense the wind is. So we could figure out the Buford wind scale yesterday because we have a formula that will allow us to do that. Isn't that exciting? So here you guys thought you'd never ever use this, and in your everyday life, you totally could figure out what the Buford wind scale was yesterday. But would you want to, right? Okay, so with that said, so basically there are models out there that actually calculate things, so such as like hurricanes and hurricane. Do you know we were in hurricanes wind yesterday? Yeah, yeah. Down in we were Category 1. And down in Colorado Springs, it got up to 101 miles per hour. Manitou Springs, it got to 99, and Canyon City got to 98.
Yeah, my dad's completely shattered.
Seriously?
What school was it?
Okay, so basically we have two applications in which you could see this. The first one I thought was really interesting how pertinent it was for yesterday. Basically there are measures of wind speed. It's called the Buford scale. And you can use the Buford scale to determine what your wind speed was, and you can use your wind speed to determine what your Buford scale is. Okay, so if you ever go into weather, be a weatherman or something, this would be something that would be highly of interest to you. Okay, if not, we're going to entertain ourselves with this. All right, so basically there is a formula here. It's called the Buford scale equals 1.69, the square root of the speed, plus 4.45 minus 3.49. So that's a standard equation some scientist has created. Okay. I will not have you create this formula. You just get to use it, okay? So basically, they're going to assume that you look out. So basically, I face west, and so I get huge. You can see the wind going backwards and forwards, north and south. You know. So before I go out and run, I go, okay, what do the trees look like? Does it look like I'll get blown off the trail or not? You know. And I do use the trees as my little scale to see how windy it is. So anyway, I look outside and I go, oh, it's not too bad. And so I plug in. I say that looks like about a level 5. On the Buford scale, so I'm going to take that value, I'm going to plug it in, I'm going to see what the speed of the wind actually is, okay? So, no, you're going to plug it in for B, because that's the Buford, okay? So I'm going to say 5 equals, okay, 5 equals the 1.69, the square root of the speed, plus 4.45, minus 3.49, okay? So I've actually just, I can kind of tell based on how things are swaying what I kind of am gearing it to look like. Based on that, I could determine what the speed of wind actually is, okay? So I have my radical expression, and so I would do number 1, and I would isolate, okay? So I'm going to bring the 3.49 over, so you can get 8.49 equals 1.69 square root of S plus 4.45. Then what would be my next step in isolation?
Divide the 1.6.
Yeah, divide by 1.69. So I'm going to flip these just because I like my radical sign on the left. I hope that doesn't confuse everybody. So 8.49 divided by 1.69 is approximately 5.02. Okay, so at this point, what would I do? Now I'm at number 2. Number 2 is what? Raise it to the power. Yep. So I'm going to raise it to the power. What power am I raising everything to?
2.
2. Excellent. So then we'll square everything. Okay. When I do that, I'm just going to bring it up here. I get S plus 4.45, and that's going to equal, it's 25.2-ish. Then I do what? Solve for S. And so I'm going to subtract 4.45 from 25.2, and I get approximately, and do you guys know that the squiggly equal sign is approximate?
Yeah.
Okay. Approximately 20.75. So the wind speed, when I think it's approximately a Buford level of 5, is actually 20 miles an hour, which I would not like to run in. It would be really windy. Okay? Does that make sense, what I just did? Okay? All right. So now, the Buford is 11. The Buford is 11. Okay? So I'd like you guys to tell me what the wind speed is when Buford is 11. Okay? So very quickly, you guys, you should have got an answer that's approximately 69-ish. 68.98 to 69-ish point something, depending on how you did your rounding, okay? So all you would do is do the 11 equals the 1.69, the square root of S plus 4.45 equals, minus 3.49, okay? And then you bring the 3.49 over, so you have 14.49, then divide by 1.69, and then square both sides. So you get approximately 69, I'm going to say approximately 69. It's in that area. Okay, a little above, a little below. Okay? So questions on that, and how we got that? Okay? Okay. So, ready to go on for another example? Okay. This example I think is actually really good. Do you guys know about, how you all drive? Anyone here not drive? If you don't drive, you want to know about this. Do you know what hydroplaning is?
Yes.
Okay. So, hydroplaning is something that you want to be aware of, obviously. It's basically when your tires do not hit the road because the water is deeper than your treads and stuff, and you can actually slide on the water. Do not brake when you're doing that. But depending on your tire and how inflated it is, the speed in which you'll actually hydroplane will occur sooner or later. Okay? So, is everyone familiar with how you should inflate your tires on your car?
Yeah. You open your car door and tells you.
So you move from, yeah, you were in 6th, but now you're 5th? All right, welcome back. Come on in, have a seat. Yeah. Yes, it does. All right, so, if you guys are not familiar with how to inflate your tires, there's on the tire. On the tire, there is a number, it says PSI, it's pounds per square inch, and that's what the maximum you should inflate your tire to. And you want to make sure that your tires are properly inflated. Number one, it helps with the wear and tear of your tire, the tires last longer. But two, especially when you're in a hydroplaning situation, the more deflated your tires are, the better chances of you actually being able to hydroplane, so the more inflated you are. And also your treads matter. If you have a very bald tire, you're going to hydroplane way easier than someone who has tread, okay? Just because the water will go through the treads, okay? Tire maintenance is huge. Huge, 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 huge. Okay, so, miles per hour. Okay? So, questions on kind of the steps we went through today in resolving a radical equation. You have the 3 steps, which is isolating it, raising it to whatever power, and then checking for the roots. On these, the story problems, you don't check. Those are just finding the answers. Okay? Yeah. Yeah, you guys want me to do this one right here?
Yeah.
Okay. Let me just make that a negative. Alright, so, on this one here, it says that my Buford scale is now 11, okay?